We're going to be talking more about functions today. We did a lot in our last unit with dealing with the graphs of functions. And today we're going to be shifting more to a focus on the equations of functions. For example, you see here I've defined the domain and the range. We've worked with domain and range already, but we did it in the context of looking at a graph. What we're going to be moving toward, not quite in this video, but soon, is how to find domain and range of an equation. So in other words, no graph, no graphing calculator, just the equation. How do we determine the domain and the range, particularly the domain? So let's look at these definitions just to kind of remind ourselves and make sure we understand. Domain is the set of all x values. So all the x values that are allowed in the function would be the domain. The range is the set of all y values that the function can have. So remember, domain is all the x's, range is all the y's. So I also want to just remind us what a function actually is. Now there's lots of, a different book would give you a different definition. This is a definition that comes mostly from one of my old teachers, but I think it's one of the best ones. And that's: a function is a rule that assigns each element of the domain to exactly one element of the range. Now what you really need to know there is that y's can be repeated in a function, x's cannot be repeated in a function. You'll see what I mean in just a second, but just to say a little more about it, you can have the same y value show up more than once. You should never have the same x value show up more than once. And just to give a quick illustration of why that's important, if you go to a restaurant, it's not a big deal if different items have the same price. So if you think about the items as your domain and their price as your range, it's no big deal if the hamburger combo and the chicken sandwich combo both cost $5. That's not a problem at all. But if the same item has two different prices, then you might not be so happy. So what I mean by that is, if you go and you're charged $5 for the hamburger combo, but the table next to you is only charged $3 for the exact same combo, that's not going to make you very happy. So it's okay if the prices are the same for different items, but probably not okay if the price is different for the exact same item. So hopefully that helps you understand a little bit why functions are important and why we are okay with y's being repeated but not x's. Okay, so here's one way you might have to identify the domain and range. They may give you a list of points or a list of ordered pairs and ask you to identify the domain and the range. So we put the domain, and typically we want to put them in order. It's not vital that you do that, but it's a good practice. So remember, the domain is all the x's. So that's 1, -3, 0, and 6. So if I put those in order, I would put -3, 0, 1, and 6. Now the range is all the y values: 7, 5, -9, and 6. So if I put those in order, it would be -9, 5, 6, 7. So that would be the domain and the range for this relation. So that is all you have to do. Put all the x's in a row, put all the y's in a row. Just remember, domain goes with x's, range goes with y's. Okay, here's something else you may be asked to do. Looking at a set of ordered pairs again, or a set of points, tell whether it is a function or not. Okay, again, you just go back to what I put at the bottom of that first slide. Y's can be repeated, x's cannot. So another way you could ask this question is, do all the x's show up just one time? So for an a here, yes, it is a function, because really all I have to worry about is I look at the x's. Each one of them is unique. There's no x that's repeated. So yes, it is a function. If you notice, the y's do repeat. There's 2 3's here, but that's okay. It's fine if y's repeat. Just x's can't repeat. So now if we look at b, -1, 5, 0, 6, 3, 4, -1, 7, we see that this does have x's that are repeated, and that's a problem. You cannot have a function where the x's are repeated. So this is not a function. But that's as easy as it is when it comes, that's as easy as it, sorry. That's all you have to do when you're trying to find out if these are functions or not. Just look at the x values. If they're all unique, it is a function. If they're not unique, if they are repeated, then it is not a function. Okay, another thing you may be asked to do is look at an equation, and they'll probably word it like this: is y a function of x? The bottom line here is that an equation containing x and y is a function y of x unless y has an even exponent. And that's related to the fact that if you were to take a square root of that y, you'd get plus or minus, but I won't say any more about that because there's no reason to confuse the issue. The point is, as long as y doesn't have an even exponent, it should be a function. So similar to the way before we just had to look at the x's, here all you need to do is focus on the exponent on y. If the exponent on y is not even, it's a function. If it is even, it's not a function. So you could say it this way if you'd rather kind of keep it positive, positive, and negative, negative. If y has an odd exponent, it is a function. If y does not have an odd exponent, it's not a function. So as we look at a, we look at y right here. That's y to the first. So that is a function. Yes, it's a function. Because again, it's a function unless y has an even exponent. Okay, we look at b, we just look at y here. Okay, yes, that's still a function. Because the exponent's not even, so we're okay. It is a function. Part C here, or number C, whatever you would say. If we look at the y, we actually have two of them. Okay, this one's fine. I know you usually don't see y being cubed, but that doesn't cause a problem as far as it being a function. However, this one does. Since we have an even exponent, that means we are not a function. Again, on D, this 3y, that's no problem, but the y squared is a problem. That even exponent means it is not a function. The last thing we'll be doing is evaluating a function. So one thing I want to make sure you understand, when we talk about a function, we're really talking mostly about the y values. The y values make a function what it is. If you remember back in Algebra 1 or Geometry, maybe, or pre-algebra even, when you used to have to graph lines and you would, set up these kind of little charts here and try to graph them, you'd say, okay, what do I get if I plug in 0, 1, and 2? All right, well, let's say for one equation you got 3, 4, 5. Then you go over the other equation, you plug in 0, 1, and 2, and you get -3, -6, -9. Well, if you notice, the x's are identical to each other. It's the y's that change. The y's are what's different from function to function. Now, to be fair, the domains can be different in that one function may exist at one may not. But that's not really the point. The point is that the y's are what makes something different from one function to another. So that's why y equals f of x, because f of x is a function, f of x equals y, so that's why we write it that way. But what we're really focused on here is this next part. F of a, what does that mean? If they say find f of a, and what they may say is, okay, find f of 2, or find f of 3, or find f of -5. That simply means plug a in for x. And this is something a lot of people just have trouble remembering, so I'm just going to try to repeat it as much as I can. Whatever's in the parentheses here, the only instruction you need to remember, plug it in for x. Whatever's in parentheses, plug it in for x. So let's look at this one for example. If our function is x squared plus 3x plus 5, and then they tell us to find f of 2, we just look at what's in parentheses and we plug it in for x. So I would get 2 squared plus 3 times 2 plus 5. Okay, if you evaluate all that, 2 squared is 4, plus 3 times 2 is 6, plus 5 is 15. So all you do is take whatever's in parentheses and plug it in for x. So now we have -a. We take -a and we plug it in for x. So everywhere I have an x in my original function, so to be clear, I'm still using this function up here for all these problems on this slide. I take -a and I plug it in for x. So another way you can think about this is I'm substituting. I'm replacing all the x's with whatever's in parentheses, in this case -a. So I was doing x squared, now I'm doing -a squared. I was doing 3 times x, now I'm doing 3 times -a. So let's simplify this. negative a squared actually will be positive a squared, because negative a times negative a would give you positive a squared. And I would encourage you to put parentheses around whatever you plug in, just like I've been doing. It helps you keep your signs straight in particular. So 3 times negative a would be our next part, and that would be negative 3a and plus 5. And that would be our final answer. That's all you have to do. You don't necessarily have to get a number every time. Basically, if you get a number in here to start with, your answers should be a number. But if you have a variable in here, then you're probably going to just have a variable answer. Okay, last one with this function. So we're still dealing with x squared plus 3x plus 5. We look at what's inside the parentheses, and we plug it in for x. So we replace x with x plus 3. We replace x with x plus 3. Okay, so first, x plus 3 squared. Please, please, please do not just square each of those pieces inside individually. In other words, don't just say, okay, x squared is x squared and 3 squared is 9. That's wrong. Squared means times itself. So what you really need to do is FOIL this. X plus 3 times x plus 3. Okay, and if you FOIL that, you're going to get x squared plus 6x plus 9. Okay, so I get that just from this first piece, just from the x plus 3 squared. Okay, so make sure you know that's not what you do. You cannot just square those two individually. You have to square the whole thing, x plus 3 times x plus 3. Okay, next up we have this where we need to distribute the 3 through. 3 times x and 3 times 3 is 9. So that's where this comes from, and then there's no really change here with the 5s. We just have to add 5. Now we'll combine our like terms. Well, x squared is the only squared term. And then we have plus 6x plus 3x, so that's plus 9x. And then plus 9 plus 9 plus 5 gives you 23. Alright, I know this is running a little long. I'm just going to do one more quick example. If we have the function 2x cubed plus 2x, and they tell us to find f of negative 1, just remember, whatever's in parentheses, plug it in for x. So we take this, we plug negative 1 in for x. Okay, negative 1 cubed is negative 1, and then 2 times negative 1 is negative 2. So 2 times negative 1 is negative 2, plus negative 2 is negative 4. Okay, here we take whatever's in parentheses, and we plug it in for x. (3b cubed). Okay, you do have to cube both things here. So the difference, in case you're curious, is here we're multiplying. It's 3 times b, so we do just cube both pieces. Earlier it was plus, and that's why we had to FOIL. So that's the difference. X plus 3 we had to FOIL. 3 times b, we just cube each one. So we would get 2 times 27, b cubed is b cubed, then 2 times 3b is 6b. 2 times 27 is 54, and we get that is our final answer.